Now you're not going to see anything useful here. We're just here to have some fun. We're just going to play around with var. I think I'm contractually obliged to go to some use cases and explain you how to best use it. But then we're going to play around with it and see where we can make the compiler do some crazy things. So I'm Nicolai, and I'll talk more about myself later. And you're at J-Fal, you already know that. That explains that slide. Let's go on. So first, as I said, some rules, how to use it. Then we're going to look into intersection types and traits, two things that you may or may not know from other programming languages, and we can see how we can shoehorn them painfully into Java. And we're going to do that. And then maybe at Hoc Fields and Methods, although there's a fair chance that we don't get to that. The slides are online, and there's a demo project with the sources that I show here, so you can go there and you can play with the source yourself. Let's get into it. Let's play with var a little bit. Let's start with some code. So usually I ask, oh, see, there's the guide here, so in case I make any mistakes. So usually I ask people where you can read that, but I guess I don't have to ask that today. That looks great. So this is some kind of common code. Before Java 11, this is how you use plain Java code to query to get some stuff from a URL. And so what I do here is I create a new URL, and then I assign it to a variable, which surprisingly is of type URL. And then open a connection, and surprise, it's a URL connection. And then I create a buffered reader, which, again, is a reader. So it feels like there's a little bit of redundancy here. This is where var comes in. In Java 11, I can just do this. I can just be, OK, no compiler, you get it. You know what these types are. You handle that. You infer types. Do I have to move, or? OK. I can just speak really loudly without the microphone. Well, I can. That was in earnest. So, quick break, I guess. Jingle or something. Oh, sorry. Yeah, thank you very much. Okay, Emma, you hear me, right? Yes, no? Am I on? Yes, okay, good. So let's continue. So what I'm doing here is I'm telling the compiler, you know what these types are. You infer these types. You put them into the bytecode, right? So that's important. There is no dynamic language thing going on here. And we can actually see that if we have a look at the target directory, where somewhere in the classes we would find the class file for this, var class file here. And this is decompiled from the bytecode. So this looks like Java code because it's a bytecode decompiled. And if we go looking for the right place, we will see this. This is not what I was supposed to be seeing here. So what we should usually see, I guess there's, I don't know exactly why this happens, and I don't want to hunt it down now. What we're expected to see is just the types exactly as I would put into the source code. So that's important. There's no dynamic thing going on. So now let's quickly discuss where this works. So this works here in a situation where we have some local variables. That's not the only place where it works, though. So for example, if we have a list of numbers, then we loop over that. Let's just paste the code so I don't have to type it all out. I create a list of, which if you're not using Java 9 plus yet, then this may be new. It's a static factory method for list. It returns a list of what you have there. So this returns a list of string. But it's kind of obvious that numbers is a list of string, right? So let's use var here. Also, we can use var here. So for loop variables, you can also have the compiler deduce the type, which makes sense sometimes. Maybe here kind of makes sense. Here, I guess int would have been fine as well. So that very much depends. And there's one other use case where we can use var. Once again, I'm going to type a little bit later. Now I want to just show you the things because these are not so very interesting. They would just have to go through these. Here's a try block. And so there's a try with resources block, and the interesting part is here, because once again I use var. Once again, I don't have to type out all of this, which in this instance is really helpful, because it's not like this is going to add a lot of information. It's just going to, well, not like this anyway. Even if you type it correctly, it's not going to add a lot of information. It's just going to add a lot of noise, and you can't really see that easily anymore which thing you have here. So I think this really improves this. Now, does that mean that var is a keyword, and every variable that you have that is called var, which You don't have that, right? A variable called var, that would be really bad naming. So since you don't have that, we don't have to discuss that. Or do you? Okay, let's have a look. So in case you have a variable called var, don't worry, it's not a problem. Var is not actually a keyword, it's a reserved type name. So the compiler only treats it in a special way if it shows up where a type name is expected. What that does mean is that you cannot have a class lower v var. I think that's fair. You really shouldn't have those. So I think that it's a fair trade-off to make. There are a couple of other things where you have to look out. For example, the compiler will infer, we'll go to the details of inference in a minute on the slide, but in general, the compiler will infer the type from the right-hand side. So if I write this, then the compiler will look at the right-hand side and will see that's a string, so I guess S should be a string. But that means that there has to be a right-hand side. I can't do this. This won't compile. Even in this case, this still won't compile. The compiler is on purpose not doing any magic here. It's just looking at the right-hand side. So the right-hand side has to be there. More than just being there, it also has to have a definitive type, which is not always the case. So what you can do is you can have a couple of instances. Spot the Lord of the Rings reference. You can do this in Java, right? So you don't have to type new int array here. You can just use this array initializer. But this array initializer, doesn't have its own type. Yes, so if I type var, that doesn't work again. Once again, that doesn't work because the compiler doesn't actually exactly know what this is. The right-hand side here is a so-called poly expression. It can be of different types, like in this case, so it can also be a long array. So the right-hand side can have several types. The compiler needs the left-hand side to decide what exactly is going on. So the left-hand side needs to define the type. That's why var doesn't work here. And the same is true for functions. So if you have a function from string to whatever, another string, let's say, what could it do? It could append something, right? So it takes a string and then just appends a space, for example. Oh, sorry. Like this. Once again, the right-hand side is a lambda expression, doesn't have its own type. That's very obvious with functions, with lambdas more than with array initializers maybe, because you already know that if the left-hand side just takes a string and reproduces a string, then you can use that lambda in all of those places. Doesn't have to be a function from string to string, can be any interface that you created, for example. So that's why the right-hand side doesn't have its own type. You need the left-hand side there, and once again, if I don't give that type add that type information, var will fail. Another thing how var only looks at the right-hand side is if you do something like this. So let's say we have this ID here, and then we have an if, and there's lots of code here, and then because it's Java Enterprise, there's also lots of code here. And then down here, somebody considers writing this. So what do you think could or should happen? So which type could the compiler infer up there for ID? Int, it's kind of obvious, right? So if I now assign it to 1, 2, 4, then that wouldn't be an int, right? So what could the compiler do instead? I think there are basically two choices. Compile error where? Right, you get a compiler at the last line because the compiler decides, look, you said it's an int, this is not an int. And this is good. It's good that the compiler is being stupid here, because what it could do without any big problem, it could just decide, look, I'm just going to look at all the assignments. I'm just going to find a general supertype. You can always use object. In this case, well, strings and integers, both of them are comparable. Both of them are serializable, so I could have something there. But the point is, if this down here changes the type of integer, changes the type of ID to something else but integer, then this breaks. And that kind of sucks. So writing code down there, and then something all the way up there, which is seemingly unrelated, breaks. So this is called an action at a distance error. And the var is trying to avoid that. And that's why you cannot do fancy things like this. You will just always have, just the type that you assign up there will be used. Then there's one other thing that is worth interest. Let's say I create a new array list of string. If you can count typos, and let's see whether I can stay below 100 or something. Okay. if you say this is names equals, which type would you put here usually? List, right? What the So I keep having some technical issues here. Right, okay. We would usually do it like this. Well, we don't duplicate string on the left and right-hand side, but we'll see in a minute why we need that. With var, names is no longer a list of integer. It's actually an array list of string. It's now an array list of string. So this programming to the interface thing kind of suffers a little bit here. I don't think it's a problem because it's just within a method, right? Methods are short, remember? So just a couple of lines. So I don't think it's a big problem. You're not likely to accidentally start depending on this specific implementation of list and then later going to have a lot of effort getting out of that dependency. Right? That's the reason for programming to the interface. Except you start to refactor. So that's the only thing where I really want to say, look out for this effect. Let's have names for each, and then print all of the many names with digit 0. Okay, now let's say I want to create a method here out of that. Now the refactoring tool, of course, decided that array list is a string, this list is an array list, and now suddenly you have the array list in this method signature here. So this kind of could lead to a proliferation of this. So what I'm saying is don't worry about programming to the interface with var. I think it's fair enough to have this implicitly as an array list. But if you start refactoring, pulling code apart, then in this case, I would definitely prefer this. And it might be nice, maybe if refactoring tools in the future would look out for this and kind of like maybe have an option where you can guess, right? IntelliJ is trying to be very clever in all kinds of situations. Maybe in this case, it guess, oh, you're refactoring something based on var. I'm going to use a more general super interface. We'll see, I don't know. Let's see, what else we have? Oh yeah, the final thing also, that's important. The scope of var is very limited. It's limited to what I just showed you. Local variables, for and try, and that's that. You can't have it in methods. You can't have it in fields. The idea is that the scope will be so limited that you can always exactly see where you're using it or what type it would be. So if it's a short method, it's just within that short method, and that would be that. Good. Let's go back to the slide. So what about readability? What I just showed you is just how it works. But should we even use this? I mean, this just means less typing, right? Less keystrokes. But it would make readability much worse. No, it's not about saving keystrokes. It might, but most of these, I don't type list string anyway. I just write new array list and then have IntelliJ create a variable there. So I usually don't type the type name on the left-hand side anyway. So this is not about saving keystrokes. This is about making it more readable by removing redundancy. The initial example that I showed you with URL and URL connection was kind of easy to read, but even that one got better with var. You have more chances to create intermediate variables. Do you remember, maybe you have remember back to something a couple of days ago, maybe you had a big stream pipeline, and then sometimes I wonder, this is a meaningful intermediate result in the stream pipeline. Maybe I want to create a variable and assign it and give it a good name. But then you end up with a stream of my long-ass name for this object, for this business object, then 2 more generics, and then you suddenly have like a name which fills all the 160 characters that you fit in one line, and then that doesn't really improve readability, right? So that's why I say, in those situations with var, you can actually create more intermediate variables. And finally, the method names align, and that might seem ridiculous, but there's a story hidden there. I give you 10 seconds to find it. 8, 7, 6, 4, 6, 4, 3, 2, 1, go. Did you see it? It's really easy to spot now. And if you have good variable names that do tell a story, and ideally they do, then it's much easier to read that now than it would be in this variant. And yes, of course I made all these class names up, but they're not unrealistically long. Okay, so there are style guidelines, and I just want to quickly breeze through them. That's a link, and the style guidelines are really official. So Stuart Marks from Oracle, who worked on var, created these. And so as I said, I just want to go through principles very quickly. Reading code is more important than writing code. Only use var if you think it improves readability. You should be able to understand what the code does by looking at that method. So at that method where you use var. If you have a method that is called get, right, and you assign the return value of that to a var variable, and you have var f equals get, nobody's going to know what's going on there. So only do that when the variable name and the method that you call are kind of like telling a story, make it understandable what's happening there. then the obvious reaction that I had as well is like, great, IDEs will just, just like have the type there. We will just show you the types if you want to. You can just click and press whatever, Control Q or Control P, and it will show you the types that are relevant there. But remember, a lot of code is viewed and reviewed outside of the IDE. So don't make code reviews more complicated. Don't just rely on IDE to keep code readable. But also, remember that explicit types are also a trade-off. Explicit types are the default, but that doesn't mean that they don't have any properties. They also trade off readability versus other factors. So don't treat it as a default. I would say whenever you create a new local variable in Java 10 or later, consider every time, does var make this more readable? And I think this will become automatic very quickly. And for demos, I, interestingly enough, still stick to a lot of explicit types because sometimes it makes it easier to see how the new API works. But for other parts, when the types are not that important, I kind of defaulted to var already. I'm not going to go to the explicit pipe guidelines. I promised you fun. This is not fun, but it's important. Go through these. Or if you're too lazy, go to the link down there. It's a cheat sheet. You can also Google Java 10 var cheat sheet, which brings you to a post from Simon Maple made together with Stuart Marks. Based on these official guidelines, there's just a A4 paper with a couple of things that can work and a couple of things that don't work, what to look out for, and how to best use it. And that's a great way to get started. I printed that, put that next to my screen. And so the first couple of times I used it, I looked at it, and now I know it by heart. Also wrote a blog post and a YouTube video, blah, 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 self-advertisement. Now let's do something more interesting. Let's do intersection types. Do you have any questions about var so far? Do you get an understanding of how it works? Great, then I'm now going to screw it up. Who knows what intersection types are? Few people. Of those who have their hands up, who use them in Scala or some other functional programming language? Who use them in Java? Oh, wow, wow, respect. Mostly the same people. So let's start with motivation. It's a bit abstract, but I'll show you an example. There's an example down there. So the idea is you have something, and you need it to implement two interfaces. So you have something, it needs to implement two interfaces. And what you normally do is just to create a third interface that extends the other two, and then you're done. But the assumption is you can't do that. I'll give you a reason in a minute. So let's say I need something that's closable and that's an iterator. But I cannot create a closable iterator. Why can I not just create a closable iterator interface? Well, because nobody knows about that interface. But so all the stuff that's out there that implements these two interfaces, of which I found one class, they don't implement closable iterator. So that's kind of useless then, right? So in some situations, I just can create a new interface. And this is where intersection types come in. So given two types, imagine types are like big bubbles of all the variables that have that type. So given two of these sets of variables, an intersection type are those variables which have both types. So that means, I'm putting this so explicitly because it's not, some people say this is a union type. This is not a union type. An intersection type means something lives in an intersection of two of these circles. So an intersection type has the API of both types, right? So closable iterator has the API of closable and iterator. So you can call close on it, but you can also call next and has next. And this is the very simple diagram for that. All the things that are closable, all the things that are iterator, and that's the overlap. And what we want to do now, we want to define a type that matches exactly that overlap. So let's do that. Let's try to make that work. Now, I talked to Venkat earlier today. I told him, like, look, I have to type all this stuff, and it takes so long. What can I do? And the great guy that he is, he gave me a good tip. He said, use the code snippets. So I did. Look, that's great for presentations. Oh no, the reformatting was not a good idea. There you go. So what am I doing here? I create a scanner. That's the single class that I found that implements both interfaces. I create a scanner, and then I throw it into first match. What does first match do? First match takes that iterator and a predicate, and then it streams over these elements. This is just a usability function that turns an iterator into a stream. So here I now have a stream of E, and I filter everything that doesn't match the condition, and then I find just any element that's in there. So what I do is give me a bunch of stuff and a test, and I give you one element that fulfills this property, if there is one. Otherwise, you have an empty optional. This is what I do here. Okay, this works. No intersection types to be seen. This just is all great and works. Now somebody comes along and says, ooh, we got a problem here. This thing that we give you here, the scanner, needs to be closed. Remember, you have to close it. And I want you to do that down here. Okay, what you do is like you put it into try, right? And just say, okay, try on these elements. By the way, there's also a new feature in Java 9. If this is effectively final, then you can just use it in try. You don't have to reassign it, which is pretty awesome. And that's that. Try that. There's the mark, yeah. And then, of course, we could have an exception. I think our exception is the right thing here. Exception. Goddamn typos. Like it's a little more complicated because it's read on. Sorry? Do I? Oh yeah. Thank you. Now I get the compiler I expected. I was already confused. Why would I get the compiler? So what do I do here? Well, you have to do proper exception handling here, right? But it's a demo, so I don't have to. I'll throw an unchecked IO exception, which you may or may not know is a type in Java IO. So, okay, don't do this. Don't do this. Oh yeah, I learned something else from Benka today. Don't do this. There you go. So now I get a compiler. Why do I get the compiler? It's obvious. This thing is not closable. Well, it is closable. The scanner is closable, but the compiler doesn't know about it. Another question is, how do I let the compiler know about this being closable? As I said, we're going to skip that step. I could just create a closable iterator interface and then put the closable iterator interface up there. And then this would work. But once again, we can't because scanner doesn't know about that interface. We want to have that intersection type. And the reason why some people already use that in Java before var is because for most of the way, we don't actually need var. Most of the way we can get with generics. Now, let's do some things that at least I found surprising. So what we actually need is we want to have something that is an iterator and closable. And we can express that. We can create a new variable here, a new type variable here, and this extends with an E, right? Yes. And you should see me at home when I type. It's much worse. Like sometimes I just leave before I smash my keyboard. So here, the Java generic syntax already allows that. So here we say, okay, we create a new variable, type t, a new type variable of type t, but it must be closable and an iterator at the same time. And we can use that here. And if everything is all right, then now the compiler should go away. Yes. See, there you go. So this is kind of cool. Now elements is both. It's both things at the same time without us having to declare any new variables. Okay, that's good. We pass it in. We pass this variable in that way. Now let's say we also want to return something that way. So let's do that. Let's paste this in here. What I'm doing here is realigning code menu. So static method, once again, the t extends closable iterator, in this case of string. I want to create a closable iterator. This is the method. The point is that the scanner, sometimes I create a scanner, but sometimes I might just create a new empty, which is just an empty thing, right? And once again, if I wanted to return a new scanner here, without this intersection type magic up there, it's really not clear what could be the return value, because the return value could be scanner, but then empty is not a scanner. It could be closable or iterator, but then I just get one of the two. So I need the same trick again to make it work. And now I want to use that up here, so it's not a scanner anymore. So it's here. I want to call that method. Create closable iterator. Let's say true. Doesn't matter. Oh, by the way, you get a warning up. You get an unchecked warning down here. I deactivated all warnings because during the demo you get all kinds of warnings otherwise. But this you get an unchecked warning here. So now that's fine. I can call this method, which creates this strange type t, which is both at the same time, and then I pass it as a parameter into the next method, which accepts a t, which is both. So that works. Now we start using var, finally, because what if I want to have a variable of this type? This looks kind of ugly, like it's nested calls. We prefer not to have nested calls. We prefer to go back to having elements here, but then we would have something here. And what this would actually have to be would be this. And the annoying part is, well, the compiler complains because it doesn't know that syntax. But it has it has these types, right? It knows these types. It could deal with these types here and down there on the first match method, so it can handle these types. It just doesn't allow us to type them out here. Enter var. We don't have to type them. And there you go. So this is now an intersection type, sneakily created by the compiler and moved by the compiler in all the right places without us having to type it out, what we're not allowed to do anyway. So there you go. Sorry? Should we try that again? Let's see whether we have more success than last time. Oh, I think I know why that might not have worked now. Maybe because there was an old version. Let's actually compile this. Because it's also, by the way, it's interesting. See, it's still even running. This is maybe the only live coding demo you'll ever see which a program is never executed. So that was my goal. I never execute this program because I don't need to. It's just about compiler frictions, right? So let's have a look here. Still doesn't work. Get back to me later. This is annoying because I think it decompiles here something like this. I think you can actually read it. But I'm going to look that up later. I think I'm just making some clerical mistake here. This is not the expected behavior. OK, so that's that. Let's go back to the slides. Let's have a look at the general use case. So I showed you this on the slides. I just want to, on live code. I just want to compress it once more. The trick is to declare this generic type here with the signature that you want, and then assign it to a var if you want to have a variable of that type. Let's have a look at whether this makes any sense at all. So this is not trivial, right? I mean, depending on how well you know generics, this might have been a little bit confusing even. And you must assume that even if you found it kind of easy to understand, not all Java developers have like the experience you have and go to conferences as often as you do. So I guess there's a fair chance that many people don't really understand this from the get-go. And that's fair enough, right? Not everybody has to know all the language details, all the language features and details. Specifically generics, specifically wildcards are something that people often don't know that much about. Me included. I just, this was the limit of my understanding, so to speak. And then also type inference plays a role here. So that means it's not really easy to understand what's going on. Then also refactoring becomes a little harder because if I have a couple of, I have a couple lines of code now and I use this var a lot and then I extract a method, just a regular extract method won't work because then the compiler is, then the extracting, the refactoring, the IDE tool is trying to find a concrete type that you can use as a return value. It doesn't know about this trick, so you have to copy paste this thing around. It's not really making life easier. But there are some situations, and this was actually, I think, fairly close to one, where there's really no other good solution. And in that case, if you are in a situation where you think there is no other good solution, which is specifically the case if you cannot change the code that implements the features that you have, the interfaces that you need. You need 2 interfaces or 3 or a dozen, whatever, and that type implements all of those. But you still don't have that shared interface. If you're in that situation and you need it without making the code wildly more complicated, then this could be a solution. So I would say it's like add it to your toolbox, but be careful with it. Don't go overboard. Don't go back to, don't be the guy who comes back from a conference and does screws up the entire code base with all the things they learned. Like now I'm going to Dockerize all of this, right? So, okay. Do you have questions about intersection types? Except what? No, good. Yeah, I wrote a blog post about that. Let's go to traits. Traits and intersection types have an overlap. So if you think, hey, we just heard this, then don't worry. So what you sometimes need to do is you have some instance there, and now you want to attach functionality to that. You want to basically say, I know it implements that interface, but I have this neat extension of that interface. I just want to, make it have that type too. So now we're going to a little bit darker stuff, not closables and iterators anymore. We're going to the future. You have megacorps here. And we have a megacorp instance. And we have an is-successful interface, and we somehow want to attach this. I will make this more concrete in a minute. So a trait is something that extends an interface that's already there and adds functionality, adds additional behavior. And that behavior is usually kind of like it's based on the interface, and it's usually very, very focused on a small thing. So is successful basically just adds a method, is this megacorp successful? And we'll see another one which is called is evil, is this megacorp evil? So we just have like a short, very limited API that we add to that. And then the language, if you want to do that, needs to offer a simple way to combine these, to attach this trait. And we're now going to see how that works. Once again, I'm going to start by copy-pasting a huge block of code to walk you through it. And this also uses stuff, syntax, that is not actually valid Java syntax. So let's throw all of this away. Oh, there we go. OK, so let's walk through this. What I want to do is something like this. I have, I want to create something that is a megacorp, but is also is successful and is evil. Right? This is what I somehow want to get at. And the reason for that is that name is something that megacorp defines, but is successful is something that is defined on the is successful interface, and is evil is on the is evil interface. And now you're wondering, why am I doing this? Well, the point here is that maybe is successful and is evil are just valid in this subsystem of in this subpart of your system, right? So the megacorp interface should not be weighed down with these additional features. It's just a small subsystem that uses these methods. But you also don't really want to have utility methods all the time. So this would be a really nice way to just say, OK, I get this megacorp from you. I'm just going to attach this functionality to the side, and I'm using it here locally. So then, ideally, if Java would allow this, how would this look? Trait then could just be, you see why the compilers are coming from. Obviously, there is no thing like trait. So basically, I want to create this is successful thing here. And then is successful is just a method that checks the earnings on megacorp. I think actually doing this would make it a little bit more obvious. Extends megacorp. Earnings is a method on megacorp. So is successful just takes existing functionality and adds a little bit extra. Then we also have is evil, which is even simpler, because all megacorps are evil. So there you go. We just want to put that in on the side. So now the question remains, aren't these intersection types? What's up here is like it's really similar. Aren't these the same? Isn't this the same thing again? No. The difference is that an intersection type is something that you would return or something that you would expect as a parameter. What we're talking about here is combining these features together. So basically doing something to create an intersection type out of something that already exists. OK, let's try to get there. There are a couple of recipes that we have to do. We have to create a functional interface. Because as I told you earlier, lambdas, and the trick here is to use a lambda, lambdas don't have a type of their own. So we can cast a lambda to all kinds of crazy things. And this is what we're going to do here. So the first thing that we need is something that we can create with a lambda. So we need a functional interface. And we're going to call it megacorp delegate. And it extends megacorp. Is someone counting? There you go. OK, like this. Of course, now we get a compile error because there are plenty of methods on megacorp that we don't implement. Let's have a look. Overwrite methods, yes, all of them. Because what we actually do is, this is the only abstract method that we have, one that returns a delegate. And what we can do here now is have a default implementation of a name that returns the name of the delegate. So I'm just wondering while I'm typing this whether there's a faster way to do this, but oh yeah, copy pasting, of course. How stupid. There we go, and then one more here, and then we're finally done with this default taxes, as if they were paying taxes. I'm not biased or something, right, by the way. It's just like I read too much Cyberpunk, that's all. OK, so the thing here is we get the same functionality. We get a name and earnings and taxes, but we now only have one abstract method, the delegate. And what we can do with that is, given a megacorp that we already have, you can't make this up. I already have one here, Setacorp. If you know the reference, you get bonus points. And what we can do now is we can have a megacorp second one. Actually, it's a megacorp delegate, but we don't need the delegate there, which we can create with a lambda. OK, so that's OK, right? So this works because megacorp delegate is a functional interface. The only abstract method it has is the abstract method that returns the delegate. And this is exactly what we're implementing here. So we're creating with lambda, we're implementing this method here, and then the other one we just get for free by forwarding to that delegate. OK, so far so good. Now, what's the next thing we do? This is just a technical thing. We have to do this. This is really ugly, and there's no good way around it, but it works. Now we can start. Oh, that doesn't work. Mildly surprised, but never mind. Oh, yeah, right. No, it makes sense that it doesn't work. This is what we would have to do then. Right? Because the lambda doesn't have its own type, I can't cast it to megacorp because megacorp is not a functional interface. But by using this cast here, the compiler understands, oh, this thing is supposed to be a megacorp delegate. I get it now. And then we can assign it to a more general type. Okay, doc, now we start implementing our traits, which is basically this here. It's not a trait, this is just an interface. There's an interface here, and this is a default method, of course. And I think you see where this is going. Interface here, and then default. And this one also needs to extends megacorp. No, this. Okay, these two should be fairly straightforward. These are just interfaces extending the interface that already exists and providing features by default methods. It's really important that they don't add any abstract methods because we need the lambda to work. If there would be any abstract method here, then we would have more than one abstract method, and then we couldn't use a lambda anymore. So that breaks down there. So now we take this, and now comes the magic part, so to speak, because now you just add them to the cast. You want to have is successful? That's awesome. What else do you want to have? Do you want to have is evil as well? Because, you know, this thing is successful. We covered that much, but we also want to have is evil, so let's add is evil as well. Okay, this is all without var, but you see the problem, right? This is the problem here. Like with intersection types, nobody knows what the type it is. But if you type var, there you go, it works now. Right? So what we did is, we took something and we just bolted on stuff on the side without adding, without creating new instances, without having to change the original interface. We just, whatever we want to use this, we just bolt on this added functionality, and there you go. This would be pretty powerful. If only it wouldn't have serious downsides, which is why I can never use it at work. I'm sorry to tell you. So, what do you think this could? What do you think the result of this call could be? Let's assume that like equals is really well implemented. The contract says, no matter which subtype you are, you only compare based on the megacorp interface. So you check, is something an instance of megacorp? And if it is, you just compare, let's say, the name, right? That would be a reasonable implementation. If two corporations have the same name, they're the same thing. If it is implemented like that, and I think, where's the class? I think I was lazy. Yes, let's do that now. Let's implement equals based on that. This is not on the plan, so this is bound to go wrong. Yes, this is almost good. Where's this one? I don't want this. I want O is instance of megacorp. Oh, come on. Right, there we go. And then this has to be final then, because otherwise you can get into trouble. Oh yeah, true. Yes, absolutely. This doesn't work, right? You have to, damn it. Don't run anything. Run nothing, right? That was the joke. Okay, I'm fairly certain. I know there's a right way to get this right. I'm fairly certain this is it. If it's not, don't worry. This equals method would be great, because in this case, megacorp would be equal to corp. Okay? We got that much. Simon, did you done taking the picture? Okay, now this is where it breaks, where it all falls apart in a horrible, horrible way that will lead to not, like if you're being fired, like this may be a good way to screw with the poor people that you left behind at the job. Where's the damn, there you go. Because what will be the result of this? Why is it false? We just implemented the best equals method ever. Why is it false? Right, the delegate doesn't have an equals. What do we do? Do we add it? Can we add this? What? Why can I not have that? Like, you're mean. Equals, they're right. If I give the right name, that actually stops working. Return, also need a return type Boolean, and then I want to go delegate equals O. Why? What's with the red squiggly lines there? It's not allowed. Damn it. It's almost as if they were not meant to be traits, which literally default methods are not meant to be. So default methods add implementations for methods, but methods that are on a class always win. And this method is always on a class. It's always an object. So giving us this compiler error is actually neat, because if you wouldn't get this compiler error, you would have just implemented a method that is never getting called. So that's the reason why you cannot have a proper equals implementation. And this is bound to break code in serious ways. Like, imagine returning, like, you do this fancy is successful, is evil thing down here, and then return the instance, and somebody takes that instance and put them into a set, and then boom. Like, why do I have 10 instances of the same corp here? Don't I have equals implemented? Look at the code. I have equals. Like, where's the bug? And then, like, I guess that would lead to some head scratching here. Hence, unfortunately, we cannot use it in real life. That's so sad. So I want to quickly walk you through what I just did. Once again, I create the functional interface with this abstract method, and everything else will just be default methods forwarding. Then I start creating my traits as interfaces, with also no abstract methods in there. And then I just cast it to the craziest stuff I can come up with, and then assign it to a var variable, and there you go. And as we've seen, so the critical thing is this: it breaks in collections and other ways as well, but collections are the main use case for equals in hash code, right? That's the reason I would say never use it in real code. If that were not the case, it would be a nice experiment, but it still has serious downsides. It uses even more crazy features than the other stuff we did before. So it's even harder to understand by just somebody just randomly walking through that code base. And refactoring, once again, like intersection types, becomes harder. And then also you need this delegating interface, and that's kind of like cumbersome. Like, we had 3 methods here, I was already getting bored during the second. Like, if you have like 20 methods on an interface, imagine how boring that would be. So it has these acceptable downsides up there, and then the critical downside down there. So that just doesn't work. So unfortunately, we cannot use this. I would say we cannot use this in real life code, which is a little unfortunate, because traits are kind of interesting. And traits, just like intersection types, are not something specific to Java. This is a general programming concept. And it's always, like lambdas, it's always nice to learn a new technique that is applicable outside of your immediate work, right? If it's applicable outside of Java, that's just good. It just means you can use more similar problem-solving skills across different languages. More on traits, blog post, mostly contain the same contents though. So at Hoc Fields and Methods, I'm not going to show you the code because that takes too long. I'm just going to show you the slides. So the idea here is that you have a type and you just want to add something, like a specific field or specific method. You know, not something like traits where you like have a proper interface. You just want to put stuff together quickly for a short period of time. And this would not make sense if you would actually have to create a new type. This is the assumption here. This only makes sense if it's short and to the point. And you can do that with anonymous classes. Like this, for example. So here I'm creating a new simple megacorp. That was the type that we just added the equals method to, remember? And then, so this is a constructor call, which I pass all the stuff that I need to pass to it. But then the curly braces here open an anonymous type. That means I'm adding stuff here, and then the compiler on the fly generates a new class for that. So this is not what I'm creating here. It's not actually a simple megacorp. A get class would return something different because it's an anonymous subclass of get megacorp. It's anonymous because, like Trump, I can't say the word anymore. Damn. Because this is, because it doesn't have a name, right? If I could add this to a regular type or just type, you know, my is successful simple megacorp, extend simple megacorp, add that stuff there. But I don't do that, so this is why the type has no name. No code. So what you can do here, you can do that with var, of course, right? So you can create this thing and then assign it to var, and then you can call is successful down here, which you would otherwise not be able to do. You would otherwise not be able to use this. Once again, I didn't show that because it was in the code, With generics, this works. So within a stream pipeline, you can create this thing, and then the compiler understands, oh, this is a stream of this crazy type. And the next map and the next filter you can actually access is successful. So the method survives as long as it stays in a generic type. As soon as it gets out of the generic type, you have to use var, like here. And if you look at this closer, if you look at the code snippets closer, the main problem is even if you use in a string, in a stream, the anonymous subclass is kind of verbose. It takes up a lot of space. Like for example, you have two things. Maybe you have to know that use case. You have a stream pipeline, you have one thing, and then want to attach some information to it, have a couple steps in the stream pipeline for filtering and mapping maybe, and then want to take that stuff out again and continue operating on the original thing that you had. So you cannot use a map, because if you use map, you just get the new thing and then you can't go back maybe. So I sometimes have this problem. I have one thing, I want to take something else and just do this and then throw it away again. So you can do this. You can have a new object which has the one thing and the other thing as, I see your head scratching. Let me at least copy paste this. There's some long stream pipeline here that should get you thoroughly confused. Where are we? Here we are. Okay. Lots of stuff. The interesting part is this. So I start with megacorps, and then I map megacorps to an object which contains two fields. The corp field, there's an underscore there, and then HQ field for the headquarter. And then I want to do some stuff on the HQ field. I want to check some things. Is everything there as I expected? Great, everything is there. Now I want to get rid of it again. I just want to map back to the corporation. These kind of things, if you want to do this occasionally in a stream pipeline, then you could do it this way, but it sucks because it takes up a lot of lines of code. And this one really breaks on refactoring. So if you want to pull out a method, then no kind of var tricks will help because that class is anonymous. And if you pull out a method, then that type would have to show up in a signature, right? You can't use var for signatures. So if I have this crazy pipeline and I decide to create a method somewhere here that pulls out part of that functionality, then I wouldn't be able to do that. So that's always bad. Having something that you cannot actively refactor without putting in a lot of work means that code is most likely going to grow more ugly instead of growing cleaner. So I think it's a little bit too verbose. Once again, combine some features that are not easy to understand, but mostly impedes refactoring. And so I think there's no really good use case. There are acceptable alternatives. Which alternatives? You can use map.entry, which I think is dubious, but I do all the time. Occasionally, I have two things. I want to have both things. Just throw them into map.entry. If you're on Java 9 or later, you can use the entry class, the entry method, lowercase e, entry method on map, and we'll create you one of these entries. So it's like you usually used to like new, I think, abstract map dot simple entry or something that was totally painful. This is much better now. If you're going to go beyond 2, or if you don't want to misuse a class that's not intended for that purpose, you can use tuples from your favorite functional programming library, or you can use records, and I'll show you that in a minute. And other alternatives for methods, this is just for fields. For methods, you can extend the base types, use utility methods, which works as well, or you can use traits, which I'll show you later, while this was not yet reordered, so it was now earlier. I switched this to the end because I was afraid I wouldn't be able to show you all the things. Okay, one cool thing that's coming up, then I'm going to let you go. What are records? What the hell are records? These are records. And no, you cannot write this in Java 10, and not in 12, and who knows when, but soonish. You write public, not class, you write public record. That's the thing, and now I just type up fields there, and if you say Kotlin, I'm going to get angry. Or Scala. Or any other language that has this for 5 years. Don't say it. What you get here for free is the compiler generates all the things, a constructor, a deconstructor, whatever that is, equals hashcode to string, accessors, all the things that you otherwise have your IDE generate, right? You just, basically what I do with this, I would write public, class, range, have 2 fields, and then spend the next 30 seconds having my IDE generate all that stuff. But then if somebody adds a field, it's easy to get these things wrong. So with records, the idea is, just you do that for me. So for these plain data carriers, you have no more boilerplate. You have no room for error in equals and hash code, which can otherwise happen. And it makes Java more expressive as well. It's not just about getting things right or getting things right in a shorter way. It's also, a record is a thing. Like that's something that people look at and see, oh, now I know what this is. This is just a collection of data, right? This is not encapsulating proper class stuff. This is just some data. Because, we're going to skip this, because the deal is with records, the API for a record models the state, the whole state, and nothing but the state. If you're okay with that, then records are your way. And what you do is you give up encapsulation. You say, look, you can couple the API to all the internal state that I have. I'm not going to hide anything. But in exchange, you're going to give me the API for free. These are records. Now, I don't think it's on here. Is it on here? No, it's not on here. Records are not values. If you think about Project Valhalla and value types, then I totally get why, because they're easy to confuse, but these are not at all the same. If you have questions about that, you can ask me later. Two different things. Although I think in the end, the use case will overlap a lot. But this is not, I didn't just show you values, I showed you records. So more about records. The Project Amber is developing them, led by Brian Getz. It was launched last year, already delivered var. That's where we got var from. And these are a bunch of links, so I can only invite you if you find these kind of improvements to the language, these things like var or switch expressions would come in Java 12, and records, this kind of stuff. It interests you. Have a look at this project, try out the early access builds, give feedback. This will be highly valuable to you and also to the community at large. I explore records, that's the exploration of records, and I forgot where that link leads, but there are also talks. Oh yeah, right, that's the JDK. There's not yet a JEP for that, so that's the JDK documentation saying this is what we're going to do. And there are already talks by Brian Getz mainly, who talk about Project Amber in general, including talking about this. As I said, I don't think this comes out in 2019. I think it's unlikely for 2020, but these are totally guesses, right? There's no public information on that. Blog post. Summary. So, remember the first 10 minutes? That's what you should mainly take away from this talk. Use var if you want to make code more readable. The right-hand side should be very informative. The method name there, for example, should tell people what's going on. Also, the variable name should be, don't have user equals get user, right? What is that user? Is it user you want to log in? Is it a user you want to, I don't know, like send someone something to? Like what kind of user do you have here? Use the very specific context that you have for a good variable name. And then the type becomes less important. And add more intermediate variables. This will make code more readable if it gets long, complex, like with stream pipelines, for example. Then, if you can do tricks with var, I think it may be worth it for intersection types. Keep those in the back of your head. And equal traits don't work because they're just not correct. And ad hoc fields and methods are just I think too cumbersome and not worth it compared to the alternatives. And that's that. I promised I want to say a little bit about myself. So I'm Nicolai Parlog. That's not me. That's what Manning forced me to put on the book, which is about the module system. I have a blog at codefx.org. I have a YouTube channel, and I am on Twitter, and blah, 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 blah. And if you want to learn more about this in a setting of your company, then you can hire me for trainings. And with that, thank you very much for your attention.